Hello, my name is Charles and welcome to another Oki Solo Channel YouTube video. So today I wanted to talk about my favorite animals on the planet, killer whales. If you watched the teaser video that I did, you might be a little surprised by this video because in the teaser I said I was working on a video on the metapopulation genetics of North Atlantic killer whales. That video is still in the works, but resident killer whales are my favorite subspecies of killer whale on the planet. And a new paper about them dropped a few weeks ago, and I'm just really excited about it, so I want to talk about it. So you might have caught that I said subspecies instead of ecotype. Resident killer whales were actually classified as their own subspecies, like recently. So Orcinus orca adder. And they've always been a personal favorite of mine. Some of my favorite scientists growing up were people like John K.B. Ford, Graham Ellis, Mike Bigg, Alexandra Morton, and a lot of the stuff they did focused on resident killer whales. So like all of my idols were working with them. And on top of that, like resident killer whales just also are culturally the most interesting to me. They live in, like all killer whales live in matrifocal societies, but resident killer whales take it to a degree that seems much more advanced. It's multi-generational, and they have some interesting strategies in the way that, like a lot of mammals, a lot of their strategies are trying to keep males away from offspring because they're these, and I'm trying to be funny here, these testosterone-riddled, like, rage monsters, and you would rather keep the babies away from that. But resident killer whales in particular took a very different strategy where the main babysitters are actually older brothers, and that also evolutionarily is intriguing because now that means that like male killer whales are raising each other's offspring. I don't know, it's just fascinating to me. It's still kin selection, but it's like a very different roundabout way of doing it, I suppose. But so this video is going to be indicative of probably several videos going forward where I'm going to try and focus on like one paper on killer whale science and talk about it, A, just because I want to, and B, because I think it'll allow me to highlight very specific things in scientific literature in a way that's like easy to connect to the dots, and are digestible. So in this case, I want to define a few things, like, for example, this one's very easy. So I'm probably have titled this video something like Resident Killer Whales of the Ice Age, or Resident Killer Whales, Ice Age Resident Killer Whales. I don't know. I'll come up with it at some point in the editing process. But like Ice Age means something very different in scientific literature than it does in like casual speak. So Ice Age in scientific literature means any period of time in which there is year-round polar ice caps. And so guess what? We're in an ice age right now. Usually when people say the last ice age, what they're actually referring to is the end of the last glacial period. So in an ice age, there are glacial and interglacial periods. And guess what? We're in an interglacial period right now in an ice age. So that's important to know because a lot of this paper is specifically focused around trying to figure out where killer whale populations were during the last glacial maximum. That would be when there was the last time there was maximum glacial coverage on land. I've been talking about ice ages and glacial periods for, I don't know, 30 seconds. And it's occurring to me that you're probably going, why does this matter? This was like 10,000 years ago. Well, it matters a lot because it can tell us a lot about what the demographic history of current populations are. And I talked about it a bit in my clownfish genealogy videos, but knowing past histories of a population can give you a lot of insight into what kind of stresses that population can handle going forward. So being able to know what resident killer whale populations were doing during the last glacial maximum can tell us a lot about what stresses they can do going forward. So like, for example, demographically, it seems like southern resident killer whales that summer around Washington state they've never really had a very big population size, so they're very inbred. So they don't handle a lot of stresses or losses to their population, so they need conditions to be more stable than a lot of populations need to be. Like even the northern residents, they're recovering very differently than southern residents are. Southern residents aren't recovering at all, and I'm sad to say that I'm not sure that they ever will. And that's really unfortunate because, so I have to define another term. It's called haplotype. So a haplotype is a set of genes that you tend to inherit from one parent. And that can be through functionally any mechanism, like maybe they're on the same chromosome, so they tend to be inherited together. Maybe they're very closely spaced together on the chromosomes, so they tend to not be separated by genetic mutations or translocations or stuff like that. All you need to know is that haplotype is derived from like haploid, as in like half genome, meaning you're only getting it from one parent. And the really cool thing about working with matrifocal species like killer whales is you can study mitochondrial haplotypes, a specific genetic inheritance that you only get from your mom. And since they live in these mom-based societies, that means it can give us a lot of insight into how these groups are moving around. And I think that means that I need to define something. So if you ever watched the Watercolors Aquarium Gallery YouTube channel, you might have seen that at some point I got really into doing whiteboard diagrams. So I brought it back, and I'm trying to hold this so I don't get glare. So the main thing I really wanted to talk about in this video was founder effect. So founder effect is a type of genetic drift that is largely driven by the fact that any sampling from a population that is used to found a new population will not be representative of the gene frequencies found in the ancestral population. So I have drawn a, let's say, oh my goodness, I have drawn an illustrative ancestral population. It's got all these colors. And so let's point right here. And we used these individuals to found a new population. Even though I took a pretty good sample of this population is very different than this one in the colors that are represented here. But something more common you would see is very few individuals are being used to found a new population. And in the case of multiple founding events, it tends to be that the last population you see is, I should say, the newest population you see tends to be the least diverse and the most distinct from the ancestral population. So you see this pattern in humans. So like populations the furthest away from Africa are actually the least genetically diverse. And you see that again with resident killer whales. So during the glacial maximum, most of their habitat was gone. Think about how most resident populations, at least in the eastern North Pacific, they spend their summers in inland fjords in Washington, Vancouver, British Columbia, and Alaska. And a lot of that was covered with ice 12,000 years ago. So that means that if we can figure out where the most mitochondrial haplotypes exist today, that could give us insight into where these populations existed during the glacial maximum. And so you'll see this term called refugia, and these refugia just refer to population pockets that existed around glaciers. And you'll probably see me use that term in a lot of future videos, to be honest. So I'm going to have to draw a new diagram here. Okay. So this is just going to be illustrative. This is not going to be an exact map. So, give me a sec. I'm just trying to make a point here. All right. So, I totally did not edit so that I could edit out that I drew this. So what's the point I'm making here? You might not recognize this at all because A, it's poorly drawn, but B, because so this big white blob right here is actually one of the many giant continent-spanning glaciers that existed. So this right here is actually Alaska. This is Russia. Down here is Japan. So all of that water was locked up in these ice sheets. And so that lowered the water level. And so that changed the entire landscape. You'll notice that like all of the Alaskan Aleutian Islands are big one landmass, and none of the like inshore areas exist yet. And so these 3 red dots actually depict, if you look at this paper and another paper, and I'm cheating, I'm including some of the data here, we find 3 mitochondrial haplotype hotspots. And this new paper described this one right here. We had no data on it, and so this represents, at least for the Kamchechnya and the other western, I'm used to thinking of it as the Pacific Northwest, as in like if you're on North America, the Pacific coast is the northwest side of it. And I keep having to think, no, I'm talking about the Pacific Ocean, so this is the Eastern Pacific, and this is the Western Pacific, and so, anyways, like the Western Pacific Ocean resident population seem to be descended from somewhere an ancestral population around this region, and the northern resident and Alaskan resident populations seem to be descended from an ancestral population that was somewhere around here, and then they colonized down the coast when those habitats opened up. And that raises like, what is this red dot? And so I can't quite seem to hone down in the papers, but southern resident killer whales either have a haplotype that is not observed in the rest of the eastern North Pacific, or they have a haplotype that is entirely unique to their population. And so that means that their population might actually be isolated today from northern residents and all the other neighboring populations that they exist now, because they're descended from a population that diverged from the rest of resident populations like over 10,000 years ago. So the new population on the Japan coast, that's the exciting new thing. Like that's an entirely new piece of information in the puzzle of like the the evolution and emergence of the resident populations that exist today. And I think that's really cool, and I just wanted to talk about it, and I don't know, I hope you guys liked it. If you did like it, please comment below, let me know. It's just a topic I'm excited about, and I like making stupid visual gags. And then I'm actually planning on doing another killer whale video probably in the next few months. So I don't know. I just wanted the fun visual gag, and I was just excited about this paper, wanted to share it with everyone. Well, anyone who will listen. If you think that's really cool, please comment below. If you read the paper, please comment below. I would love to hear your thoughts on it. And if you have any topics you would like to hear my take on or my perspective on, please let me know. Like, comment, subscribe, and all those other things. Until next time, stay curious, have fun, and read a cool paper about resident killer whales.